have things that are like super easy to integrate. You might have to do more than one thing, right? So on this one, you do need to integrate that, but first you need to write it as a limit, right? So this is going to be the limit. We liked b, I think. B going to infinity from 0 to b of x over e to the x dx. And then you have to integrate that thing before you can actually take the limit. So we like taking u being what? X. So du is going to be dx. Are we doing parts or substitution right now?
Parts.
We're doing parts? Okay. So if that's u, what's u prime going to be? Well, you can say dx. Please say dx. Please say dx. So if that's the case, what is v prime going to be?
E to the negative x.
E to the negative x dx. So what's v going to be?
Negative e to the negative x.
Negative x, exact. Very good. You need that negative in front of there or the whole thing folds apart. So when you actually apply this, what do we end up with? We know that this is going to be equal to the limit as b goes to infinity. Don't let me be lazy here. We end up with, what do we end up with? U times v, right? Is that how you started off?
Yeah.
So x e to the x times, not e, it's negative e to the negative x, right? Minus the integral of, what was it? uv prime?
So it's just negative.
It's x, u, and then v prime. Is that it?
Should be
I thought the x
e
is
to
gone.
negative e to negative
Which one is it? So what goes right here?
v. V.
V goes right there? So negative x to the negative, like this?
Yep.
dx. Is that correct?
Yeah.
And we're going from what? 0 to what?
B.
B. And this gets evaluated from what to what?
0.
0 to b as well. So is this a little bit of busy work? Yeah, it is a little bit of busy. Oh, you like this one. This is a cool one. It's 0 to 4. I like this one. Oh, come on. What topic is this?
Trig sub.
Trig sub, right? This is that weird, rare case when you can actually do that kind of stuff. What do we need to factor out of the denominator effectively? 1 over 4. We want to make it a 1, so we factor out 1 over 4 because when you cross the square root barrier, it squares it, right? So what is this thing equal to? 1 over 4, 0 to 4, dx over the square root of 1 minus x over 4 squared.
Should it be denominator to b?
It will be. We're going to do that in a second, yes. We'll do that in a second. Anyway, I'm just doing that right now. Now what do you see?
Inverse sign.
You do see inverse sign at this point, right? But the point is you have to be careful here of what. Is there anything in particular we have to be careful of? The boundary, right? Because can you plug it? They're 2 dx's? Oh, sorry. Thank you. Correct. No, thank you. They're suddenly multiplying, unlike the population of Russia, apparently. Hey, I can tie anything together. That's right. Why can't you plug in 4 into this?
You can't have a 0 defined.
Yeah, all hell breaks loose when you divide by 0. The truth of the universe unravels. So instead, you're going to do this as 1/4, the limit as b goes to 4 from the left, right? Mm-hmm. Of the integral from 0 to b of dx over the square root of 1 minus x over 4 squared dx. And at this point, it's just a matter of using what?
Calculator. Algebra.
You can't pull the parachute, man. It's a backpack. You can't pull the parachute. Why am I writing the dx? I don't know. It's substitution at this point. It's just substitution because you're trying to create something that you can doubly substitute, essentially. In this case, how about sine of x is equal, how about x over 4 is equal to sine of theta? Why is that a nice substitution? Because when you substitute that in, what do you end up creating? You end up creating cosine squared, right? So you end up with 0 to b dx over the square root of 1 minus sine squared theta dx, right? Now, stop it. We're not done. This is messy right now because how many variables do you see in this integral?
2.
We're not doing that yet until we get to what subject? Multivariable, exactly. Different things will happen. We will integrate with more than one variable. But in this case, we can simplify a little bit. You know, you can do it in pieces. It's 4 to the left, 0 to b, 0 to 4 of dx over cosine squared, square root it. What do you get? Cosine theta. At this point, it's much happier, but you're still with that problem of 2 variables. What do you know, though? You know that x is equal to 4 sine theta. So what does dx equal? 4 cosine d theta, right. So what do you end up with? Instead of dx, you have for cosine theta d theta. And what's the magical thing that happens? You get to do this magical thing, which is the point of the entire exercise. Goodbye. Exactly. So then you have b4 to the left of 0 to 4 of 4d theta, right? And what do you end up? Oh, then this cancels too. Oh, that's kind of cool. So what do you end up with? You end up with the limit as b4 to the left of what? You integrate this, it becomes theta from 0 to 4, right? But what's the answer to that? 4. No? Did I do that too quick? I can't hear you. Sorry, I went too fast. Go, Ray. Oh, good catch. I just failed at the number one thing I annoy myself. Well, no, I get annoyed by, right? These are what values?
X.
Yeah, exactly. We know that x is equal to 4 sine of theta. What's sine of 0?
0.
0. So that stays 0. But what does the top become? Well, it's just. Well, what does it become? Oh, I'm sorry. Excuse me. I have to be very careful here. I'm sorry. I just made a double mistake in here. These are x values, right? So 0 equals 4 sine theta. Yes. What is sine going to be?
Sine could be anything.
Yes, but can 0 work?
Yes.
Can we put 0 there?
Yeah.
Yes. As far as I can tell, we can put 0 there. If this folds, I'll come back to it. But what do we have to do on the other side, though? 4 equals 4 sine theta, right? That's kind of nice-ish. 1 equals sine theta. So what does that theta become? Sine inverse of 1, which is pi over. Is that true?
Yes.
Yes.
Oh, yeah. The sine of what is 1?
Sine of pi over 2 is 1.
Oh, yeah. Thank you.
Well, this explains how they got their answer in pi over 2.
Good. Nice. So is it okay for 0 to pi over 2? There you go. So that's a lot better. I guess this would be the symptom of you're really close to the end, and then you add wrong. That's essentially what just happened here. Be careful of those limits. If you do substitution, you're absolutely correct. Absolutely correct. You need to change those limits. So what does the answer come out to be?
Pi over 2.
Pi over 2. Isn't that neat when it comes out to a nice answer like that? I don't know. I like it. What u substitution could you do? Excellent. Yeah. What could you let u equal to?
X minus a over square root of b.
That's awesome. Right, because you want, what's the only difference here? You want this right here to turn into that right there. Doesn't matter what it's called, you want to turn it into that. Yeah, so how about that? I love that. That's really good. So you let it equal x minus a squared over.
B. So just x minus a over square root of b.
Oh, is it over the square root of b? Why does it need to be?
It hasn't gotten to use square, so you can use the improper.
Oh, I see what you're saying, because then it would just be u. Very cool. I see what you did there. Because if you did that substitution, you would have e to the, you'd have an e to the u, right? So if you did this right there, u squared is equal to the proper thing, right? Oh, very cool. I like that. That's really neat. So then what happens? Notice that, oh, u squared is equal to this. So what then does this integral become? If I do this substitution.
Square root of b.
E to the what?
E to the negative u squared.
E to the negative what? U squared? Exactly. But then you have this dx, correct?
Mm-hmm.
You have this dx. A and b are both going to be what?
Constant.
Constants. Again, not multivariable, they're constants. So we need to replace dx with
du.
something du, right? How do we go about finding that?
Taking the derivative.
Yeah?
Take the derivative
Of the sub, what we decided it to be. So what is du going to be on this case?
of 1 over square root of b.
Du, just so, hold on, let me just do it out a little bit. U is equal to x over the square root of b minus a over the square root of b, right? But since x is the only variable in there, du is just going to be 1 over the square root of b dx, because when you take dx of that, what happens?
Gone.
It's gone. There's no x in there. It's constant, right? So what does dx equal? Square root of b du. Where do you plug that in? You plug it in up there. So you end up with the integral of negative u squared times what? The square root of b du, right? And this is going from what to what?
Still infinity positive.
It's still negative infinity to positive infinity. Why?
Because you just multiply by.
Because you just multiply by a constant. It's still getting infinitely bigger, infinitely negatively big, right? So what's nice about this is b is a what?
B is constant.
So this is this, right? But what do we know that this is equal to?
Pi.
Square root of pi. How cool is that? Side note, did they show us that?
No.
They just told us that. My thought, when the book shows you stuff like that, I don't know. I would love to attempt that maybe as a side note. Someone could do it. So what's the answer going to be?
Square root of B pi.
B pi. Yeah, you can put them together. Right. They just tell you that that's equal to pi.